Hi everyone, welcome back to yet another episode of our podcast series Future Ready Systems with Krishna Kumar. And today, as always, we have Mr. Krishna Kumar, AI architect and modelization specialist. Welcome, sir.
Thank you.
So we are back again with yet another section.
Oh.
And in the last episode, we talked about how AI feels slow in the real companies and in the real world scenarios. And the one insight kept coming up was like the problem was not with AI, but with the system.
Yes.
And one of the major part of the system is how the data is stored and how it's accessed. So today we will be discussing about how to select the best database.
Yes.
Okay, so there are so many options out there, MySQL, PostgreSQL, MongoDB, Firebase and Snowflake. Why is it so overwhelming for the companies to select a database that is best for them? What is the one thing they are missing out while selecting a perfect database?
Good question. Basically, it's like you already decided what car to purchase, but not decided what engine you have. See, database is basically the engine of the car, or the engine that needs to run behind the AI interface. This is what normally confusing at times, but more often it's about the guys or the architects who are deciding on what database should go with. They don't look at what is the data you really have. It's like you purchase a car with a mileage of 800 miles, especially in EV, and you hardly drive 50 miles a day. End of the day, you're home again. Why do you need a range of 800 miles? It's not utilized. If you have a range of 200 miles for any scenarios, urgent scenarios, or any power breaks, you're still happy with 50 miles a day. So this is what normally happens with database. People don't really try to break down or understand what actually is the kind of data you have. Even if it is optimized and polished, what is the kind of data you can expect to have in a very positive thought process or positive estimates for the next 2 years or 3 years the maximum. It's not that you over-engineer something for next 15 years. It doesn't make sense there, because what you have today is what is going to run on it. So this is where the major problems start surfacing. It doesn't come up till the time it's all implemented, it's all running, people start using it. Then you find your infrastructure bill is too high, and as people start using it with a lot of complexities in this, you find your system slowing down. This is where the major concern or the problem that never crops up to a friend, but is what plays in the back end.
So you should always know about your data before purchasing the database.
Yeah, any architect should basically understand how the company works, what works it do, what kind of data is stored, to a very positive estimates. If you look at what kind of growth we may have, what kind of new data may crop up in the next 1 or 2 years. It's not that there are very few of those 1 million company growing into 100,000 million company. It doesn't happen over 1 or 2 years. It takes time. Same way, so you need not plan for 100,000 million. At least you should look at planning for 2 years, 3 years kind of growth, and take an estimate with that growth percentage. What can be expected? How long can this be expected to run? Because technology, it keeps on changing overnight. You don't even need an overnight to change that. So new things keep on coming, new architectures keep on coming. You have a lot of scope, lot of place, lot of space where you can expand. So it's not important what is the best you want. So normally what this technology space, the people look at a lot of the data or videos that flow in the social media about the new products, new databases, new features, and we go for the one with the best feature. We never think back, are these features really needed for this? If these features are not needed for you, why do you want to go for that is the next question. Just for the hype of it, just for telling someone or showcasing that this is the data structures you use. No, that's where the major problem comes in.
Okay, sir. So let's start with the most common option available between the MySQL and PostgreSQL. Which one should the company choose? Like, what kind of data do these databases store well?
See, basically, Postgres and MySQL are like two hands of a single person. They are all structured data where the data are stored in tables and rows, like columns. Like once the Oracle CEO had told 1 decade back that in Oracle you can store everything other than your father and mother. So that was the concept of a database. You can put everything in a database. So same way, it's just very structured. You need to have links connecting between different tables properly done up. The normalization needs to be done. I don't know how many of the database experts today still remember normalization, but that was the mother of creating any database and still is. When you start creating a database, that's on a relational model or structured data that we call. See, the structured data, the benefit is it's very stable. You have the data correctly laid down into it. You have a strong query process. We can get retrieved data faster on that. And the limitations that it's not flexible with schemas. You can't just go and keep dumping it in any kind of data. There is no structure, no play around, nothing like that. That's a limitation of it. Now, when the architects get into the play, do we really need or are we really going to use any unstructured data, data without any schema, without any layout, different formats? Are we going to use that? If no, then this is the best bet. Why go ahead with that? See, always all frameworks you get a database, different databases have different frameworks. They have their own pluses and minuses that keeps on growing and coming down every maybe a quarter or a month because they all are upgrading. But the basic structure of any structured database that we use, a real-time database, we call a relational database. It just means you have relations between the tables and the fields. That's more than sufficient for most of the companies. A good number of companies, they need not think beyond that at this stage at least.
So it's best, MySQL and PostgreSQL will be best for structured database.
It is 100% structured database. You need the data to be properly fine-tuned. The structure of the database should be properly made and relational connectivities needs to be there so that you have the data that's very strong, can be retrieved pretty fast, the query timing is very less, and this is what everybody needs. Any AI needs what? You give a question, the answer should come back in microseconds, not minutes. It works.
Yeah. Okay, that makes sense. The structured data fits well with relational systems. Okay, but what if the data doesn't fit into the table? Like, when does companies need to look at MongoDB and Firebase, and what is the trade-off that comes with this flexibility?
Yes, there's a big trade-off. See, why do someone need to go to NoSQL kind of database? It just means there is no structure, no relationship, nothing. It's like go to a supermarket, you can keep on dumping whatever you want, whether it can be liquid, it can be solids, it can be semi-solids, it can be powders, anything, you can keep on dumping. But in a structured, you can't do that. You need to move everything around into that structure. So, now why this kind of database? The question is, you are creating logs of lot of happenings in a server or maybe in a system, you are creating logs. Those logs grow huge pretty fast in days or hours it starts growing with the number of users logging and using that. Such logs, different activities being logged at different places, you have JSON payloads that's coming. In such scenarios, when these mixtures are coming in, you need something like a NoSQL because you can just pick up something and place it into this. Yes, the benefits is the schema is highly flexible. You can use any kind of data into that. Yes, there are expandable pretty fast. The horizontal expansion is so easy and fast. But now there are some cons for that. What doesn't work? In case your data can be moved into a structured database, the best option is do that. If it is something that cannot be done, your data is unstructured, then the only reason why you should even think or dream of going into a NoSQL thing. Else what happens, your data becomes inconsistent over a period of 6 to 8 months, and you don't find how to create queries and how to generate reliable outputs and consistent outputs. Every query should be giving the same output. Those consistencies, that reliability, those starts losing over a period of time. When the data is possible to be structured and the data is needed for those kind of reviews, those kind of analytics, those kind of CRUD operations. So always make sure you move into a NoSQL only if you have lot of data of different structures, without a different structure and with different structures coming into you, like JSON payloads, logs and everything. Else, I would suggest if you can structure your data, get into a structured database mode, a relational database mode.
Okay, that's a clear differentiation between the databases. I hope viewers got a great idea about the differentiation about that.
Basically, it's not developing an application that simple, and people have tried to make it so simple, they forget about the basic consistencies, basic rules, or the basic foundation that you need to create before even starting to key in a line of code. On the contrary, with the hype of vibe coding, with the hype of these LLMs across, people are straight away, what they do is they start putting on the codes. When the codes come, they start thinking now where to put it. They put up any database they feel easier, they are learned on and start dumping into it. In these scenarios, even structured databases are never normalized for their 4 to 5 key characteristics, and you find even structured databases having multiple duplicates across multiple tables, and the data size grows pretty fast. Whereas it could be controlled, it could be cleaned up, but that doesn't happen because you don't have process. It's just cost cutting everywhere. You can't cut costs at these places. You can't cut the cost while developing the engine. You can't cut the cost while getting a tire for the vehicle, because those are the things that's going to make you live or die. Yes, you can cut cost on the upholstery. It will make you a bit uncomfortable, but you can still reach your goal and destination.
Cost cutting at the wrong places can be more costly.
More devastating, basically. Because these cost cuttings will lead you to rebuilding the whole application, the whole data structure from ground up. And other than that building, they need to clean up the older things and then create a bridge so that they can be pushed into the new ones. And that's a huge task. Not for the kids to play around with. They need people who have been into this for quite some time.
So we have covered about the operational databases, but there are tools like Snowflake or BigQuery. People often hear about them. Why does most companies misuse them? Like, where do they actually fit actually?
As I say, you hire an architect, database architect, who has been working, for example, in Microsoft or maybe Apple, and he comes up with his ideas and background here, and he starts designing the applications, backgrounds, databases on his thought process of how the data he handled there. See, this data warehousing, your Snowflake or BigQueries, these are not databases. They are basically data lakes, we can say, lake. In the real human term or literate term, if you use the word lake, it's a vast pool, vast area where you have lots of water. Same way, these databases or data lakes are vast places where you have lots and lots of billions of data lying there. Now, question is, why do we need this? We need this, and these can be used basically if you have pure analytics. What happened over a period of time? By taking these analytics, we estimate or project what can be the future. Those are the kind of analytics that runs pretty fast on this, because it can churn in or digest huge chunks of data and spit out results. These are these are different layers basically. It's not a database. Databases are primarily the relational databases always. And these can lay over that so that huge chunks of data can be digested fast and you can get analytics. These things cannot be used for transactional data. It cannot be used for real-time applications. But people forget that.
Yeah.
The guy who has been working in data lake for long, he has a nice resume showing his data lake. These founders or legacy transactional tech leaders, they always think of the hype that comes with those words. Are they really those needed? I had an experience a year back. I had a founder where it was a small startup who had a big dream for managing and analyzing data of the retail industry basically. Yes, the transactional model is there always, but he was looking at some analytics to understand what kind of sales can happen in this particular period of time, what happened last 3 years. And that was what he needed. He didn't need what happened last 20 years. And he needed a projection for a year or the coming quarter. Now he was talking of straight away starting only with data lake and nothing else going on. Does this transactional data work over database lake? He has never thought of. Someone told him data lake is big, you can handle lots of data. Yes, it can do, but do you need that? That's the question they need to ask. And people start building the whole database over a data lake, and finally they find it's all a lot of junk data, like a whole room full of library books lying in a whole room, big room, or a hall you can say. Now how do you find what you need out of that? Data lakes can give you analytics, these kind of books available here. These kind of books were issued, they can give you. But really someone wants to pick up a book, take it home, you will go mad, unless it is a proper structured library. So that's the only difference between structured data and unstructured data or data lakes kind of thing. People should really understand what the business logic is, what they have been doing, what they plan to do in the next 2 years, and with this serial information, what kind of data they will have. And then only you can take a decision whether you want a data lake or whether you want a structure. And with the structured relational database, do you want a layer of data lake? Or is not needed, or just a NoSQL is sufficient for you? That decisions need to be taken by analyzing the existing data and the expected growth over a period of 2 to 3 years. This is where most people, the tech leaders, fail and go with the hype of having the best with everything, expecting that in future, 15 years down the lane, they may need it. But by the time you're reaching somewhere 8 years, this all is obsolete. It's not going to work out anything for you.
I think people often underestimate the need to do some research onto this.
More than underestimation, is the human psychology basically that comes into play. We want the best.
Oh, okay.
The best with all the bells and whistles together and the cheapest.
Okay.
So there is no combination between these two. All the bells and whistles and all the features available. Do you really need this? Are you really going to use it? And how difficult, in case you are planning to use it, how difficult and how long term is the implementation and the cost over that? Is it worth the effort you are making? That's the bigger question.
Yeah.
If you are having a sales of 10 million or 50 million, do you want a database, data lake which can give you those kind of data? You don't need that. So this is where we should understand what is needed and what is not needed. What kind of technology we need for our use and find out where it is available. Rather than what we do is we finalize on a tool, on the technology, and then we see how I can fit my data into this. It should be the other way around.
In search of best, don't choose the wrong one.
Exactly. Choosing the wrong one will have long-term problems, long-term escalations, long-term money spending. Managing will be another headache.
Yeah.
You need teams of those expertise, which is really not needed in your organization. It's like everything going haywire. For running a small organization, a medium organization, you are not running a Boeing company's inventory to have a data lake there, right?
Yeah. So analytics is its own layer, that's clear. So what about the raw performance? Where does something like Redis come in?
Yeah.
And why do teams often misunderstood what it's really for?
Yeah, this is the same question. I had a call in the morning 3 hours back with a guy in the US, and he was planning for developing an analytical engine for some analysis, and he was often saying, I just want Redis there.
Okay.
I asked him, why Redis? Redis is not a database. It's an overlay over a database, and you surely need a database. Then we discussed and came to a scenario something like this should be a combination of two databases. One can be a vector database, one can be a structured database, a third can be a layer over that, Redis, which can be, this data can be cached into that and the outputs be faster. And Redis has its own limitation because this is not used for permanent storage.
Okay.
It depends on the memory you have.
Oh.
It's a short-term memory. They pick up, they keep it down there. So your memory size that you have, the infrastructure that you paid for, defines how fast and how better the Redis can work. Redis is a very fast engine. It can give pretty fast results. But yes, this is the grounds for that. And do you need such kind of data? For someone to see the dashboard of what happened yesterday, does he need something that should be coming off the fly? Like a rocket, answers should become no. So, do we need that?
Yeah.
And secondly, always Redis is an add-on. It's an extra cost for getting things faster. It's not that you can replace with the database. And people confuse there a lot.
Yeah.
What happens is today everybody has access to internet and lot of data is being flown around the world as noise. Now what to pick up out of that noise and how much to go through that to technically understand how that functions, number one. Number two is having an overall relation. Yes, there is something like Redis, there's a caching kind of environment. That's sufficient for the leaders.
Yeah.
The remaining data is knowing for the people who are on the ground. But these leaders should not try to attempt to architecture a database with this half-baked knowledge. This is where things go wrong and things break at times.
We should actually understand what our needs are really. No?
At the end, the bottom line is, unless you know the business logic, how the business have been flowing, how the data has been growing, how the input of data happens, this if you don't know, you cannot even dream of developing a database. And people who do this without knowing this, without spending time in studying this, is what create databases that are over-engineered. You need a small server to run your database if it is clean and nicely polished up, whereas you have been running a cluster on auto-scaling mode, which keeps on scaling up and down as the data queries start coming. And it's unstructured, it's unclean data, to be very honest. There is no proper schemas that's been developed. There is no proper relations that have developed. If you need faster data, you need to plan to put a Redis over there. It's a layer that can give faster outputs. But you cannot just think that Redis is the whole database. It cannot happen. There is something that needs to happen in the background also. You need something else also there. These are the learnings, these are the architectural things that people should understand, take time to understand, take time to read, and then start developing it. Here is where most of the failures, even for founders, number one. The second is for the tech leaders who have been into tech domain for around 20 years, 30 years. Someone like me, 3 decades I have been into technology. But if I think the Oracle 8.1 I had learned 20 years back is going to help me, that is what Oracle is today, then I am wrong. It has changed upside down. Unless I study a summary of what Oracle is, what all on a top level, eagle eye level I can do, and then I have an architect who is today working on to this for the past 6-7 years. Because he has been transitioning from one version to the other version, he knows how the transition happens, how we can move the data with, how we can make the changes needed so that the data doesn't break and it migrates. This is the kind of experience you need when you're migrating. Unless you have this, this is where 90% to 80% of the migrations in this world breaks at times. Or a 6 months migration project goes into a 18 months migration project because of this. Wrong people, wrong knowledge, wrong understanding of the current application, wrong understanding of the current data structures is what breaks or makes a migration. Now you think, do you want to migrate with a peace of mind or as if you are jumping on a bed of coal burning red. It's up to you.
I think they will think twice after hearing this.
They need to think twice, else they are breaking things. The whole company breaks off. A small data mismatch somewhere while the transition or a migration and not being checked properly before going live makes the whole thing break off. We had seen a lot of last such experiences even in very big environments. Even in the government organizations we had experiences in the past. Where there were data breaks, new systems were brought in, but the people had a lot of problem utilizing it. But one of the best examples of doing this properly, keeping it slow and then migrating slowly, growing that faster, was the UDI, Aadhaar of India, which was conceptualized by the governments but brought in and architectured by Nandan of the erstwhile Infosys founder. The growth process, the data structures were nicely made that so many millions of data, billions of data into residing, still from any point of this country, you connect over a mobile data, you can retrieve the data you need. That's what databases are. That's the reason they should be built. Now, if this, I don't know, but if that is built over a data lake, do you think your company needs a data lake? Or it's a over hype and over expectation, exaggeration that you're doing? Yes, just to sell that my company runs on data lake. Only that can happen. Results won't be there.
When companies try to navigate all of this, where do they go wrong more often? Like, what are the mistakes you see often the companies making in the field?
Let's take it the other way. Let's see, tell them what are the key secrets they should go on, or if they don't do those things, where they break. Now, it can be that way. Now, choosing a database based on hype, based on something that you read in Twitter, read on Hacker News, is not the right database for you. Now, people has to accept that on face value and understand and take it to the heart that I should build what I need, not I should build what the market gives you. There are a lot of billions of companies. Every company is different. They have different data structures, different requirements, different quantity of data, different outputs they need. Please don't understand, don't accept, or don't try to think that it's one boot fitting all the legs. It cannot fit. They are different sizes. So that's the rate custom comes in always. So same way, make sure you don't choose a database based on the hype that you find in the market. And number two is a poor designing of the database. Designing a database is more important than designing your logo or design the front end of your company. This is more important and more complicated. It's not technical complication. It's basically how the people who are doing it understand the database structures that you have, the data layers that you have, and connect and make something with their brains that these databases are properly connected and interlinked and relational. This is not something that LLMs can do for you. You need human brains for that and experiences doing this. The next is over-engineering early. Don't just think, yes, I'm going to put up a big thing that can accommodate. It's like you're a bachelor and you are purchasing car. I need a 7-seater, I may have 4 children, I may have their grandparents, their wives coming in. You're purchasing a car now when you're a bachelor for this category, that's going to happen 30 years down the lane. That's what we call absurd or stupidity. To be very honest, the wrong words on a podcast, but yes, this is pure stupidity. Never do that. Don't just over-engineer your systems, it's not going to help you. And you're trying to solve future problems. Future, maybe a decade later, these problems may arise. Don't try to solve a problem that is not available today. It's like you are pulling out the problems from the air and trying to solve it. No, if there's a real problem, solve that problem. That is what is going to help you out. That's how the systems will be stable for you. That's how you'll get results. You'll get an ROI. There's an ROI word every management runs behind.
Yes.
If they need this ROI, it should not be over-engineered. That's when they are going to get the results they are looking for. The money they are spending for is worth the time. Else, it's like something you're putting in a drain to be washed away by the sea waters. Now, these 4 things, if you can take care as a tech founder or as a tech leader in your company, your migrations, your setting up things, your growth, scaling of the data structure, scaling of the ERPs is going to be easier and comfortable. Oracle database or Oracle ERP is not for all. We know that. SAP is not for all. Now, if I come and tell you I need the data structures and database of SAP for a 20-man, 50-man, or 100-man company into manufacturing, are we really going off the roof? So, make sure what you need, understand that, and see what you get for what you need. Not what you get and how do you adjust that to what you need. These 2 things are contrary to each other, but this is what will help you make something successful, make your life easy.
I hope the leaders will reflect on this seriously.
They need to reflect on that, else there's a reason 90% of the startups fail. These are one of the reasons, not all the reasons. One of the reasons is this: 90% of startups fail, 80% to 70% of migrations either extend their timelines, overshoot their budgets, or they fail. And we still go back to the yesteryear software we run on that. These are the reasons. One of the major reasons is the data structures and databases you have. Somebody has to understand that. We don't blame the world saying that developers were wrong. It's not about developers alone. There's a different category of people who you need there. What different exercise that needs to happen. If you skip that, it's gone.
So if someone right now listening to this feels like their system is already struggling, and how do they know it's time to rethink their database setup? Like, what are the red flags they should be watching out for?
It's like you will find some red flag coming up daily in your operations from your operations guys. They will be jumping around with some problem and affecting from your data that you have. One is the slow performance of the whole systems you have made, the applications that are running above that. The performance decreases as a result of the queries become slower to you. That's one of the major red flags that you always find. Even though a few may be measurable, but a few may feel that, but it may not be really a very big red flag, because you may improve the infrastructure there, you may improve the systems there, so a bit increases. But if you measure it technically, the data flow time that takes from the initiation of an API or a query to the result coming in, you will know exactly how slow it's going from what it was before. The second is the messy data. As times grows, there are duplicate entries, unwanted data. Lot of data is messed up so much, you cannot rely on it to an extent. So you come to a situation that you cannot rely what the results that are coming are really correct or not at times. See, what is the human nature? Once you get a wrong result, even if you get 100 times the right result, it's still the fear. Is it right? That fear comes in. And that is what degrades the performance of the whole company, basically, the whole staff there here. The confidence in the system goes off. And that's one of the major flags that you should have. And then is a pain in scaling an application. The scaling has become a big pain because there are a lot of messy data, a lot of system blocks. Now, how to scale that is a big issue. Many a times, it becomes a roadblock for many companies to scale. So that's why we say it's time you migrate to newer technologies, newer framework, do the migration properly, and do piecemeal migrations, not a Big Bang Theory kind of migration, and then you get the results automatically coming up. The ROI is faster than you even predicted. So never do a Big Bang migration, do piecemeal migration. That's for the ease of the human nature, human psychology. Adaptation becomes easier and simpler do that, and you are successfully on the same road to success. You are not following a different path from the crowd that's going on. Then the major problem comes when you integrate some new things into the system. Integration is pretty tough, pretty unmanageable, lot of effort, lot of workload. Many a times it's not a straightforward integration. You need to catch your nose round the way, and those are the major problems that you can help you flag that yes, there is something wrong somewhere. That flags can really help you out.
Okay. So the warning signs will be clearly visible. You just need to act on time.
Exactly, it will be visible day in and day out. Every day you walk into office, you will find some signal. Only thing is you should open your eyes and ears and read and understand those signals.
So if we remove all the complexity, all the vendor marketing and the competing options, what actually matters when it comes to a database? Like what's the core?
The core is, as we always talk, we have been talking earlier also, the data has to be clean. Any systems, any applications, any AI running over it can only give what the database provides. And database is not magic or God. If you give in garbage, it's not going to give you out something good. It's going to give you garbage only. Now database, what you give in, it gives out, but in different formats. AI, if you give garbage, it will amplify the garbage and give it to you. So at the end of it, if the data is garbage, you are going to get garbage whatever you put over there. So make sure your data is clean, nicely structured, accurate, consistent and well maintained. This will help solve 50% of your problems. Remaining only 50% you need to deal with. Then comes create simpler data structures. Don't complicate things. Don't create complex things just because you know how to create complex. Create complex only if it is needed, or make it pretty simple, easy to implement that. Implement it the way the business works, not implement the way you learned that. If you implement the way the business works, it becomes easier for the business to go around it, go through it, and come out without hiccups and without speed breakers. If you do the other way, it's stuck with that. The business has to change that. No businesses should not change. It's the data basis that should change. It's the data structures they should change. The complexity within the data should change and make it easier for the business to run. We are not complicating the running of business. Databases, AI applications are to ease the running of a business. We should think in that proposition. Not that if I made a complex query or complex thing, people who see that will appreciate that. Who is going to see that? Maybe a CTO. The maximum, even he may not see the manager, he may see the query. Whom you need to make happy is the management, so that they have the systems and the company running smooth and the business grows. People should look at the higher thought process and a higher level rather than going at a very low level and start doing things. Then this easy access of data. Data should be easily accessible to everyone. In the sense, as per your security clearances, as per your requirement, you need the data to come to you faster, consistent and reliable data. These three are the major keywords in this. If these three things are there, any migration is successful 100%, and any migration that's done has a faster ROI than that was presumed or drawn on a chart or a map. It's faster, 100% faster. Only thing is, do it properly, you are successful. If there is a break, if there are cost cuttings you are doing there, you are going to have a bad time. You may get things cheaper in the beginning, but as the scale keeps on moving, 6 months down the lane, you would feel like you need a team to manage this whole thing. Whereas you don't need anybody to manage if it is properly done up. That's the major difference.
That makes sense. The core is the data itself.
Yes. Any car, the core is the engine. So unless the engine performs, you are sitting in a cardboard box.
Yeah. So that ties back everything together. In the last episode, we talked about how system slows the AI down, and today we talked about how the database plays a big role in that. So the real question the leaders should be asking is, are you choosing the right database for your needs, or are you over engineering before even realizing what your needs are?
Yes.
Right, sir?
Yes, yes. Basically, the problem is not about the database now. The problem is about the clarity. The leaders, the implementers, they should try to especially implementers should try to study and understand the data that's available today and what growth can be there, and then pick up a tool that's implementable, rather on the other way around, pick up the best tool they find and try to fit this into that. That's the only change that needs to happen. For this, you need clarity. Clarity is what can help a business grow, what can help a business fall. Same way, clarity can make a database hold on the fort for you, stable for you, and fast running for you. And if loss of this clarity will make pieces crumble down, you run around, pick up this, pick it up again, those environments, those scenarios will keep up coming up. See, it's not about what's the best database. It's about what is the simplest way of putting these things in a table, whatever sort of table or database, and making life easier. Rather than what best is available and how can I put this into that. So this is the only difference that can make or break your organization, make or break your whole applications, make or break your AI tools. Everything can happen. A simple question that every tech leader or every implementing architect should answer is whether what is needed today can be run for tomorrow also in the simplest and easiest method. One liner, if they make it to print out that, put it in front of your server room and the database guys sit, this should help you be successful.
That's a simple explanation.
Yes.
So instead of asking what's the best database, we should be asking what's the simplest option that can solve our problem today and can solve the future problems also.
Not future, tomorrow.
Tomorrow.
The future is too long.
Okay.
Who knows who's going to live by that future?
Okay.
So it's for tomorrow. What I suggest is any tech leaders who are looking for migrating or even dreaming of migrating their legacy applications into new frameworks, new technology, they are not doing it for fun. The migration is being done because there is a problem, and the problem is scaling, problem is flow, problems with integration. That is the reason you are moving out. You are migrating it, and when you migrate, take care, you get the right team, and then talk to them, make them and spend time to make them understand your data flow, your business logic, how the company works. At that stage only you should think about designing a database, and during this stage you can take a decision on which is the easiest way to achieve my goal of inputting data, retrieving data in the formats I want. Simple. If that's achievable, you are successful. I will never think of doing this as a big bang implementation. Always do that at piecemeal, because the implementation becomes easier. Any problems, any upgrades you want, you find it out earlier and can make those change and go with the flow. Else, at the end of the day, you plan for a big bang migration and some company does it. Those company people don't even have an idea of how you operate, how you function. You are moving towards a valley, a deep fall valley. And I'm sure no tech leader wants that in their span of being in command at the company. They want that to be successful. So find the people who are good, who can do that for you with confidence and responsibility. Also, don't cut costs there. Cutting costs won't help you. It's very simple. Someone who is good at that work will bill you for that. Someone who is not good will do it free for you also. Will do it cheaper cost. You must have seen today's scenarios. A lot of people looking for co-founders. I want a co-founder who can build the whole tech stack for me for free. I'll give equity. If he's doing nothing, he may do. If someone is good at his job, he will never be doing nothing. He will be doing his work. And he won't come for free for you. So you are asking for garbage to coming and do it for you. The same way with the migration, it's not an easy job. You need a lot of qualities in that. Find the people, find their confidence, check out where they're ready to take the responsibility of deliverables. That's the most important thing. And now, anybody within your circles is looking for a migration or are stuck with legacy applications or old applications that was not well designed or well developed, and now you started finding the red flags coming out at places, times. It's time, think over that. We can support you. We can have a discovery call to understand on an eagle-sized view what this is about and how that can be overcome, how we can go plan a migration on that. Then we can take this further. Feel free to share this podcast to your friends and tech leaders within your circles.